All right, good afternoon. We're going to get started. Thank you for sacrificing your Thursday at 4 slot. We'll try to keep it engaging. With me is my colleague Itai Maoz, who's one of our engineering manager, and my name is Nir Mashkovsky, and I'm one of the product managers for ElastiCache. So what we'll go through today is a little bit of a background about ElastiCache. We'll talk about trends we see in the industry that lead to the need for a product like that. And then we'll spend most of the time briefing you on what we've done in 2019. So how many people in the room use ElastiCache? OK. Redis? Cool. So we'll try to go through the background very quickly, because obviously you know more than I do about ElastiCache. Hope not. Cool, so we literally live in an always connected world. We have billions of devices connecting to the web all the time and to the cloud. And most of all, we are now in this viral world, right? So you can have these things that spike very quickly. To be able to build applications like that and handle the needs of our customers, we need to be able to trust something to give us very, very low latency and very, very high throughput. So this is a blog by our CTO, specifically talking about our philosophy of purpose-built databases. So instead of doing one-size-fits-all or a Swiss Army knife of databases, our approach is to have purpose-built and make sure that we meet what the customers need, even if we have overlap between databases. When we look at how we categorize databases, we look at where the data is being stored, how it's being stored, and what API do you use to access that data. Today, we'll focus on where we stand as a service, key value store, which is a format that's very easy for you to be able to communicate data to customers. It's not about optimization like it is with relational. And then in memory, which is where the data is stored. So this is where sort of ElastiCache is located. So when we look at scenarios where this product is used, there's really two categories. One is acceleration. So a lot of you are using ElastiCache or Redis to accelerate other systems to make your database run faster as far as users are concerned. And also, and very exciting, distributed state. So if you look at the other use cases, they're essentially keeping state for a new type of microservice-based architectures, which we see all the time coming up. So today, we support two in-memory engines. We support Memcached. Memcached has been around for a long time. It's a very stable open-source product. In terms of functionality, it's focused on as a key value store. There's less functions compared to Redis or less capabilities. And in terms of maturity around things like disaster recovery and scalability, it's less robust, meaning that if you have data that costs you a lot to recover, you might not want to put it in Memcached. Redis is where a lot of the traction in the community is right now. It's still very fast. It provides these mature features that we'll go through, like scalability and security. And it's also providing a very, very rich set of APIs to manipulate data and to store data in formats that are useful to you. Redis is also very popular in the industry. If we look at the Stack Overflow survey, I think it's the third year in a row where it's the most loved database. You don't want to know what's the most hated one, but we can talk about that after the session. And it's also the first, ranks as the first database in key data store in this dbengine.com survey. So a little bit about Amazon ElastiCache. Basically recognizing this need in the industry, we built a hosted service that supports Memcached and Redis. It's deployed in all of the regions for AWS. And it's been around since 2011 as a service, and since 2013 supporting Redis. So there's a lot of maturity, there's a lot of lessons we've learned, and a lot of that capabilities we're passing to you in terms of managing Redis for you. So just double-clicking a bit on what I've just talked about. Really, our theme as a team is to provide you with maximum performance for minimum headache. We try to take care of all the stuff that's expensive and hard to do, like making sure all the certifications are handled, and we try to keep providing you more performance for a lower price, and that's something that we'll hear a lot about in the next section. Okay. A little bit about our customers. We talked a little bit about use cases. These 4 examples are really kind of canonical to what people are doing. With Expedia, they're doing basically query acceleration. They're using ElastiCache to make sure that they don't go to the database for each query. Grab and other ride-hailing companies are using ElastiCache to essentially manage the drivers and the passengers around geographic locations. And without the performance and the scalability, it's very hard for them to do this sort of calculation in real time. With Fortnite, it's again it's a session situation where you have people playing together, and essentially those are shards in your Redis database, if you will. And with GE, we're seeing this pattern that comes around microservices, where you have these very large applications coming into the cloud these days that are totally stateless. People spawn this huge amount of Kubernetes pods. They have thousands of containers running, but they need something to coordinate them. And we're seeing more and more customers using Redis for that because of the performance and scalability aspects. So with that, I think I'll hand it over to my friend Itai to walk you through some of the stuff we've done in 2019 and show you a demo.
Thanks. Thank you, Nir. All right, so we actually did innovation across multiple pillars, across performance with Enhanced I/O and T3 instance. I'm going to elaborate more on this in a few minutes, and also going to show you a demo. And with scaling up and down, horizontal scaling, vertical scaling, we did a lot of improvements here, and everything is in an online fashion. We doubled down on security. We're going to talk about, Nir's later going to talk about how much we invested in security with additional features, more than what we already have today. We maintain compatible with the open source, because we know a lot of our customers, they love us because they also love the Redis and Memcache open source. And then we added more functionality for the fully managed. So this is including your own self-service patching, so you can control when and how, and also with a migration tool. So we talked about how much Redis is so popular. And the most popular key value, according to DB Engine, it's the most loved database, right? And but self-managing it is hard, which is why we built ElastiCache to begin with. And so what I'm going to do now, I'm going to show you a demo of this. I'm going to talk about this feature, then I'm going to show you a demo, and then I'm going to talk about performance. So why is it hard to manage Redis? Because you have to take care of a lot of things. You have to do all the OS patching and software upgrades and configuration management and the daily snapshots. And you have to, and it's really hard to have high availability, because you need a monitoring plane, and you need to make sure it's available across multiple availability zones. And you need to have failover workflows. And it's hard to scale, both vertically and horizontally. If you do this manually, there's a lot of things that can go wrong, and it's very error-prone if you don't do this correctly. So you would need to do all of this. And it ultimately boils down to a lot of investment. Investment in automation, investment in tools, investment in engineering, reliability engineering that will have on-call 24/7. So that's a lot of investment. So we have this ElastiCache that does all of this for us. But our customers, and maybe some of you are also have self-managed Redis and also ElastiCache, have asked us, okay, so how do I migrate? So we have a few big customers that we have worked together with them on the migration, and they build like a custom solution. And some other customers did this in an offline fashion. You know, you take a snapshot, and then you restore that snapshot later on, which is possible, but it requires some downtime. So we built this feature to migrate from self-managed Redis on Amazon EC2 to fully managed Redis on ElastiCache. And the tool helps you with migrating everything in real time to ElastiCache. And then once the migration completes, you can immediately update your client to point your traffic to ElastiCache. And now I'm going to show you a demo on how I'm doing this. All right. Sorry. OK. So this is a pre-recorded demo, so things will go more smoothly. So what I'm going to do in this demo, I'm going to show you how I'm creating my own EC2 host, just like you would do in the console. And then I'm going to install Redis from open source, from GitHub. I'm going to run Redis, and then I'm going to run performance benchmarks. And then I'm going to migrate it to ElastiCache and compare the performance. There's overall 14 steps. Unfortunately, we didn't demo all the features, but we did demo this because we found it interesting, and a lot of customers have been asking about it. So the first step that I'm going to do is I'm going to go to the console and create those instances. So I already created them ahead of time to save time in the demo. I created an R512 extra large. This is a memory-optimized instance. It's very good for caching, very good for Redis. It has 384 gigabytes of RAM. These are the IP addresses, both the public and the internal one in the VPC. We will use them later in the demo. And I created also a C5N host, which is used for the client. This is where I'm going to send the traffic. This is going to be the client side where I'm going to do the load generator and send traffic to ElastiCache, and before that to Redis. All right, so what I'm going to do next is I'm going to go to my EC2 host, and I'm going to install Redis. This is an R512 extra large. So I'm copying, I'm cloning here the Redis from GitHub. And now I'm going to check out Redis 5, which is the latest stable version of Redis, of open source Redis. And now I'm going to compile it. As you will soon see, within about 2 minutes, we were able to download it from GitHub, compile it, and run it. So it's really easy to use, really simple, and it's part of why Redis is so popular and why a lot of people would like to experiment and try Redis. But we know it's also hard to manage. So what some of our customers have been doing, they've been doing something like this, installing their own Redis, and then whenever they're ready to move to production use cases and to the fully managed experience, they will migrate the same way that I'm going to do this right now. So the compilation will finish in about 10 seconds, and then I'm going to start the Redis server. Once I start the Redis server, you might be familiar with this if you're familiar with Redis. This is how it looks like when it starts. And then we're going to exit this host and use only the client side. So the next step is that I'm going to copy a bunch of scripts. I already copied them ahead of time, so I'm going to skip that. I will tell you what those scripts are doing further on in the demonstration. So now I'm going to go to my client. This is a different host. This is the C5N that I showed you. And I'm going to go there, and I'm going to start sending traffic to the self-managed Redis. This is just an alias I put here to help me with the demo. So I'm running this Redis benchmark wrapper. I'm going to soon show you what it does. And then I'm running here a metric collector from the client side, and I'll show you this as well. So the Redis benchmark, if you are familiar with Redis, it's an open source tool as well that you can use. What I'm doing in this script, I'm actually just doing a simple wrapper for this. The first step in the script, I'm just killing all the existing Redis benchmark processes. I'm going to use it later on when I'm going to shift traffic. And then what I'm doing here, I'm starting 20 processes with one single write client connection, and then another 20 processes with 4 read client connections. So overall, 80 read client connections, 20 write client connections. We're using 250 bytes as the value sizes. So this 80% read, 20% write, it's with 250 bytes value sizes. It's pretty common and typical to what we see with ElastiCache customers today. So that's why a lot of our benchmarks are using similar values to this. So next, I'm going to look at the metric collector. When you use ElastiCache, you get a lot of server-side metrics. But in order to show this here in the demo, and I'm also using the self-managed, I'm using here client-side metrics. This is a very simple script, and just a very basic, just to show the performance and that we're going to look at the end of the demo. So you see I have here a loop. I'm getting as a parameter the host name. It's first going to be the self-managed. Later on, it's going to be the ElastiCache one. And then I'm going through this loop. I have a separate tag for ElastiCache and separate tag for the self-hosted one, so I can later on look at this. And then what I do every 10 seconds, I call 2 functions, very simple functions. One is to get the DB size. I'm using the CLI command to do this, and then I'm publishing this to CloudWatch. And then in the requests per second, I'm doing something very similar. I'm getting the total number of commands processed. I'm subtracting the previous value, dividing it by those 10 seconds, and then I get the average request per second. This gives me, and then publish this in CloudWatch. So this gives me kind of good, very basic client-side throughput and DB size metrics that we're going to soon use this and show them in CloudWatch. All right, so the next step is that we're going to store something that is unique to us in this demo. So as I said before, we have 40 Redis benchmark processes running. I just started them 2 minutes ago. And I'm going to take the process IDs and I'm going to store them in Redis. You can think about this like a smoke test, right? That you want to see that what you put in there, it's actually replicated to the ElastiCache, and you can read it later on. So this is what I'm doing here. And as you can see, Redis stored this. That's not really surprising. All right, so the next step, now we will show the next step. We're going to look at the configuration of the Redis, the replication info of both ElastiCache and the self-managed. But before that, we'll create the ElastiCache cluster. So going back to the console, as you can see, I created already an ElastiCache. I'm using the same R512 extra large host, the same exact instance type that we used before in EC2. And I'm doing this so I'll later be able to compare apples to apples. And when I compare apples to apples, I will run traffic to both of those and see the results. And from the get-go, I created this with 1 master and 2 replicas. And the reason there is 2 reasons why I did it. The first is because this is what you would do. When you would create ElastiCache cluster, you would want from the get-go to have another replica, at least 1 more replica for high availability. And the second reason is because I want to show you that this works also when you have replicas connected, so it's not just a master. So you have also when you have replicas connected to your ElastiCache master, it will still work the migration. But later on, when we do the comparison analysis, we will we will only send traffic to the master, so it will be apples-to-apples comparison. Looking at the replication info on ElastiCache, we can see that it has a role of master, and it has 2 replicas connected to it. So that's exactly what we just saw in the console. And then looking at the replication info for the self-managed Redis on EC2, we see that he has a master with no replicas. This is how we just created this in the beginning of this demo. All right, so now I think we're kind of ready to start the migration. So what we're going to do is going to go to the console, and we're going to click Migrate Data from Endpoint. Once I click Migrate Data from Endpoint, I will put the private IP of this self-managed EC2 host, and then I'm going to click Start Migration. What this will do is it will start a workflow that will initially start the migration. And as you will soon see when we look at the replication info now, you can see that the same commands I just ran 30 seconds ago, you will see that now the roles have changed. So now ElastiCache became a replica, a slave, and the master is that self-managed Redis on EC2. So this is what we see here. And if we look at the self-managed one on the EC2, we can see that now it has 1 replica, and that's the ElastiCache. So replication is ongoing as we expect it to be. Now we're going to start collecting metrics for ElastiCache as well, the same metrics that we used before. I'm already running this, but I'll kill it and start again just for transparency. I didn't really have to do that. So now we have metrics collected, and we have the replication flowing from the self-managed to ElastiCache. Let's go to the console, and let's see how it looks like. So going to the console, and we look at the CloudWatch Matrix. In the CloudWatch Matrix, what we're going to see is that when we use the Redis benchmark wrapper, and we have, as I said before, 100 client connections with 40 processes, we're able to push up to 200,000 requests per second to our self-managed Redis. That's what the R512 extra large, the vanilla ones, can do with when we push max traffic to it. And then now soon we're going to refresh this graph. And what you will see is that once we started the migration, there is some traffic to the ElastiCache as well. ElastiCache is the blue line, and the self-hosted one is the orange line. I know it might be a little bit hard to see from here. Okay, so as you can see on the screen, at some point we're doing 20% of the traffic to ElastiCache. And that's because, not because that's where we max out ElastiCache, but that's because that's what we're replicating. If 20% of the traffic is right, then we're going to expect 20% of the traffic to be to ElastiCache. And as you can see, we have about 186 requests per second and 37 thousand requests per second to ElastiCache. Looking at the database sizes, we can see that after the migration, ElastiCache really quickly catches up, and then now the database sizes are approximately the same. This means that the clusters are likely in sync, and this is now just ongoing replication. This is the steady-state replication that you have with Redis. All right, so we're almost done with this migration. We have to click on the last step, and the last step is the stop live migration. So when we go to the console and we click stop live migration, we're actually starting the last step, the last workflow in this migration. So if the clusters are in sync, then it will succeed, and if not, it will fail. You can have a force mode checkbox that will stop anyway, but if you don't click it, then it will only succeed if the clusters are in sync. All right, so now we started this workflow. We're completing the migration, and now I need to wait for this to finish to change the endpoint. So what I'm doing here, I have a script to change Redis endpoint, And what I'm doing in this script, I'm just waiting for the last step of the migration to finish. This typically takes 1 or 2 minutes. Let's see what this script is doing. ElastiCache supports SNS notification, simple notification service. And you can get notification with email and mobile text and Lambda, and you can have an endpoint with an API. And what I did here is using SQS, simple queue service. And I'm just doing, this is like a really simple script that I'm polling this queue all the time. So I'll get the message whenever that migration finished. When you do your own client application, you'll probably do something different because that's depend on what you have in the application. Once we receive this message of replication migration finished, we know that we're done. So what I'm doing in this specific script, I'm running again that same Redis benchmark wrapper. So exactly what we saw before with the 20% write, 80% read, using the same exact script, but this time I'm sending this to the ElastiCache Redis master. So as soon as we get this message, we're going to call this script. I don't know how much it's visible from the distance, but this is that script. All right, so in about 20 seconds, this migration will complete. What you will see is that a lot of Redis benchmark processes are starting to run once this finishes. And like I said before, you will probably not do this. You will do something a little bit different. It depends on the client. But you will do something that will listen to those notifications and change this in the client side. So here we go. We didn't have to wait that long. We have those processes running. So we know that the migration finished successfully. So now let's go back and just verify a few things. So first, let's look if the roles have changed back. So now I'm looking at the self-managed Redis, and I see that it has a master but has no replicas connected to it. So that's good. That's what we expect to be. And then I'm looking at the ElastiCache master, and I see that it assumed back the role of a master. It's no longer a replica. It's no longer a slave. All right, so if you remember that smoke test we had in the beginning of the demo, so let's see if this data was migrated. And if we're going to run this command, we're going to see all the process IDs that I stored in the beginning. So that's great. This is working. So now the interesting part. So I know that some of you are already using ElastiCache and might not be entirely interested in how we do the migration. So now let's talk about performance. So going back to performance, what you will see in the console is the difference between the traffic that we were able to push to the self-managed Redis on EC2 versus what we were able to do to ElastiCache. In the beginning, we're able to push up to 200,000 requests per second. That's where we max out the R5 12 extra large Redis that we self-managed. Okay, and then later on, we started the migration. And as you can see, about 20% of the traffic is going to ElastiCache, as you might expect it to be. But what's interesting is once we complete the migration and we start sending benchmark traffic to ElastiCache, you see a huge increase in traffic. So you don't only get all the fully managed capabilities and functionality and the security and everything we talked about with ElastiCache, you also get significantly better performance using the same instance types and with the same client load generator. So that was pretty cool. And as you will soon see, it will stabilize at around 450,000 requests per second compared to 200,000 requests per second that we were able to do on the self-managed Redis. So let's look at how we did this. All right, so let's talk about performance. And our performance journey actually started a year ago in Q4 2018 when we launched the optimized M5 and R5 instances. And on the team, what we're constantly doing is we're trying to find the best, to give you the best value for your money. which means getting the best price per performance and also the best performance. So let's look at this. So here you have the blue line. The blue line is the R4 instances. Those were pretty strong and popular up until some time ago. And then AWS introduced the Nitro system. I don't know if you have watched Werner keynote today, but he did talk in more details on the Nitro system. And with the Nitro system, we're able to get from 120,000 requests per second to 200,000 requests per second. So that's a significant performance improvement. And this is the 200,000 requests per second that we saw in the demo. But we did not stop there. We said, OK, now let's optimize them even further. So we did some kernel changes in the kernel drivers for the networking and in the operating systems on the AMIs that we use and on these instances. And this got us to 30% even more improvements in performance. So that's the red lines that you see here. So this is part of our performance journey. And we saw up to 144% better performance than the R4 and 30% better performance than the vanilla R5s and M5s. And then we also saw latency reduction of up to 25%. But we did not stop there, and our journey continued. For us, this is just the beginning, and we're going to continue work on performance improvements. So let's look at what we did this year. So some of you may already know this. Redis is a single-threaded architecture. And it has a lot of advantages. It's simple. There are no race conditions, no complex synchronization mechanisms. It's easy to extend it. It's easy to understand it. And then it's easy to support this rich functionality, which is part of what makes Redis so popular. And then it has this shared nothing architecture, which means you can scale by sharding and horizontally. And it also improves cache coherency because data is not bounced between different CPUs. So how does it work? So if you have a single threaded architecture, so you have one client, and if you look at the latency of the commands within Redis itself, those are microseconds. This is really, really fast. Redis is super fast. But when you have more and more and more clients, and this is typical Redis use case. In typical Redis use case, you have hundreds of client connections. And when this happens, we can see that at some point a bottleneck in the throughput. And that's exactly what we saw in the self-managed Redis, that we were bottlenecked at around 200,000 requests per second. So we profiled this, and we saw that about 70% of the time is spent in the I/O layer, in the communications. So we thought, what if we do this in parallel? So of course, if you have one client, it doesn't make a lot of difference. It's actually just an overhead of another thread. But if you have more and more clients, right, then it makes a difference. And we're able to push significantly more throughput by doing all the socket communication on separate threads. That's something that we released with Enhanced I/O. And the results, as we saw before, we're able to push 450,000 requests per second with Enhanced I/O on those instances. So we see here a nice increase in performance in our journey, starting from the R4s to R5, vanilla R5s, optimized R5s, and then Enhanced I/O. And this is how we got more than double the performance than you could get with vanilla Redis on vanilla R5s. Very similar performance results with the M5s. So this is how our performance journey started, and we're not done yet, but this is what we did this year, which is pretty, I think, pretty impressive. One of the things that is interesting is that in all of these, in both of these optimizations, we did not change core Redis. We did very little changes to core Redis. We don't want people to have a problem with the way Redis behaves. We didn't want to change anything. So we found the nice trick is that we did this without changing core Redis and doing this with the Enhanced I/O library, which is mostly separated from Redis and very little code changes. All right, so my last slide is about T3s. And we talked about R5 12 extra large. Those are really good for heavy-duty kind of instances that you would use for massive production use cases. If you want entry level, either it's for test or dev, or even if you have like small use cases, the T3s are really good. And what's good about them is that they can handle burst CPU usage. And what we're able to see is that it can sustain up to 3x the traffic that you have compared to the baseline, compared to the steady state. And this helps you because it gives you better operational stability in case of unexpected traffic spikes. Overall, we also saw better baseline performance compared to the T2s. We did this both for Memcached and for Redis and different workloads. So it varies, but we overall saw better performance with the T2s. And then two more cool things. So one, we price it at the same price as T2s. So you automatically get better price performance just by scaling up to T3s. And also it's free tier eligible, which is good for trying out and experimenting with this. And then the last thing is that you have online scale up from T2 to T3. So it even doesn't require any downtime in case you're using T2s today. And with this, I'm going to hand this back to Nir, who will talk more about our improvements in this area.
Thank you, Itai. So what we've seen was really cool, huh? So just to summarize, if you have Redis running now on EC2, and we have a lot of customers that have a little bit on EC2 and some on ElastiCache, you can now migrate your workload without taking downtime. And you will know that your cost per transaction has gone down significantly by essentially those 240%. So again, with the same theme of trying to give you the best performance for the least amount of headache in terms of management. So I'll go through some other areas where we made improvements this year. Let's start with security. So with security, we're looking at sort of three pillars. The first one is access. When we start building an ElastiCache, when you build your first ElastiCache cluster, it's isolated inside a VPC. So no one can attack it from the outside, from the public internet. The pattern we see folks using in terms of access is to add a few front-end machines, either web servers or some kind of external facing thing that is open to the internet and communicates with your Redis cluster. The next step is encryption. So we support two modes of encryption, encryption at rest and encryption in flight. Obviously, this is the ability to encrypt traffic between any node that talks to your Redis server, and also the traffic between your master nodes and your replicas is encrypted. This is a very simple setup. When you set up your cluster, you will choose to have it support TLS, and we'll generate a certificate and set it up for you. The next step is encryption at rest. When we talk about encryption at rest, we talk about obviously your backups, your snapshots that you take. We allow you to schedule snapshots for your data and obviously create new clusters from older snapshots or recover data if you have an issue. You can do up to 22 backups in a day. And the next step for encryption at rest is for swap files that may happen if your server gets into swap if you're using a lot of memory. So anything that will be on the disk if you're using this encryption at rest is going to be encrypted. This year, we added the ability of you to use your own key that is managed in your KMS, meaning that the key for your assets belongs to you. And you can take one key and use it for more than just your ElastiCache. Imagine an application that has several tiers and it deals with sensitive data. You can now use the same set of keys to encrypt all of the data in all stages of this application. So that's available to you right now. The next step is authentication. So we talked about access control, we talked about encryption. and now we talk about authentication. Part of the value of Redis that Itai was talking about with the single-threaded architecture is simplicity. Due to that, Redis is pretty rudimentary in terms of security. I'll talk a little bit later on about Redis 6 that will have more capabilities. But right now, Redis supports one password that can restrict access to all of the commands in your Redis server. What our customers were saying, especially compliance customers, are saying, hey, we need to be able to rotate our passwords. We need to be able to get to a situation where we have two passwords or tokens live at the same time so we can do a deployment without killing our clients that are still using the old password. So we want to be able to drain it. Since we can't predict all of your use cases, right, it might take you a few days to drain all the old clients that use the old password. What we essentially enable is the ability to have two passwords at the same time. You can create a new password, take your time with moving it to the client, and then kill the old password by removing it. So you can't have more than two at the same time, but you can have those two for as long as you need. So that's kind of part of our commitment to flexibility, to making sure that you can do your own maintenance scenarios the right way that meets your business needs. Another feature that exists in Redis is the ability to rename commands. We've seen a bunch of customers coming in and say, hey, due to some mistake, we ran some destructive command, like we deleted all the keys in a production database, and how can we avoid that? Again, what Redis open source supports is the ability to change the name of the password. So you can take change the name of a command. So you can take a command like get or set or delete and rename it to something completely different. It's sort of a very cheap way to create RBAC, to be able to have different people be able to use different commands. But that's what is available right now. What we've done is enable changing command names in real time without having to recycle Redis. So if you use open source Redis, you want to rename your command, you'll have to restart your node. With ElastiCache, you just go ahead and change the command name, and it happens in real time. In Redis 6, which is supposed to come out early next year, there's a new set of functionality around usernames and around the authentication and resource-based access control. And as soon as that drops and goes to production, you will see us supporting that as well. OK, so scalability. Just to put us all on the same page, when we think about scalability, we think about two axes, if you will. One is scale up and scale down. So it's taking the resources in the server you use now and increasing them, CPU, memory, and so on, or networking in cloud case. And scale out. In the case of scale out, it is essentially adding more unique compute units and taking your application out. Scale out is obviously better. It's better in terms of cost and in terms of reliability, because even if you lose a node, you still have a lot of nodes that allow you to do that. So how many people are familiar with cluster mode in ElastiCache or in Redis? Cool. So Redis comes in two flavors, cluster mode enabled, cluster mode disabled. Essentially, with cluster mode disabled, you have one master and as many replicas as you need. In ElastiCache, it's up to 5. And your data is replicating to the replicas, and they are read-only. In cluster mode enabled mode, what you do is you shard your data. So you can have many masters, and each of these masters would have a replica. It's important to understand that picking a replica is up to the client. So Redis clients that are cluster mode enabled have to query the server and understand which replica is in which endpoint. And that way, you're able to scale out, essentially. ElastiCache supports scaling out and scaling in without taking downtime. So that's, again, something we support. And we support overall a cluster size of 250 nodes, where you can mix and match the number of masters and replicas. So what have we done in 2019? One of the core asks from you, our customers, was the ability to migrate to new node types. So, for example, you have a T2, now there's a T3, it performs better. You want to be able to change node type, again, without taking downtime. We've introduced that a few months ago, and now you can essentially get all of these axes of scaling, scale up, scale down, scale out, scale in, without taking any disruption to traffic to your cluster. The other pattern that we see in terms of scalability is in cluster mode disabled case, which is still a large percentage of people who use Redis. And in that case, it's obvious that you don't want to put too much traffic on the master. The master is doing your writes. So the pattern that people tend to use is to write into the master and read from the replicas. The problem with that is that if one of the replica fails and a failover happens and now that replica becomes the master, the clients might not know about it, and again, you don't want to read that from that replica anymore. So to handle that, we introduce a reader endpoint. What reader endpoint does is basically uses Route 53 to abstract your read replicas. It round robins on the read replicas if you have more than one. And if you have a failover, it will essentially remove that read replica that became the master from that load balancer, and you will have an undisrupted read experience. So your reader endpoint is always stable. So we've talked a lot about how we sort of do the heavy lifting. We take away a lot of the complexities of running Redis. But we still need to enable customers to sort of control their own fate in some cases. For that, we introduce self-service updates. Essentially, for some of our customers, again, that have compliance regimes, they need to be able to perform updates when it's convenient for them. We used to have this service window, which was very draconian, right? You have to make sure that you don't have a lot of traffic during that, and so on. Now you can consume an API or get a notification from us when an update is available. And inside that data packet about the update, it also tells you when it expires. So you're able to schedule your updates when it makes sense to you. A lot of folks are scripting that using lambdas to consume the feed and then script the updates in their own slow times. And then you are able to do that through the console as well. So again, that's a feature that showed up a few months ago and is very helpful for customers. So to summarize what we've talked about, again, maximum performance, minimal headache. The things that we focused on this year is really rounding out the product, making sure it meets scale, performance, security, and compliance needs, as well as meeting the open source compatibility and making sure that we're able to release the latest and greatest in a very predictable and fast cadence. So obviously, there's a lot of more information about Redis. This is the last day of the convention, so I believe we're the last session about ElastiCache, but you can go online and consume training. And do keep in touch. These are emails. You can get in touch with us. And finally, if you want us not to get fired, please do us a favor and provide feedback to the session. Thank you.